Okay, hello everybody. It's very nice to see you. We already met some of you yesterday and the day before. My name is Vita Tilvikien. I'm from Lithuanian Research Center for Agriculture and Forestry, and slides are opening. I have two slides to introduce also our institution. Yes, it works. We are from Lithuania, very small country in Europe near the Baltic Sea, and we are a state research institution. We work as separate institution under the Ministry of Education and Science. We don't belong to university, and the main research is applied research that we do at our center. In 2023, we were about 200 researchers, and in total, we have about 500 people working at our institution. The number is huge because we also have our big experimental fields, and we own a farm about 1,700 hectares. We have 67 PhD students, and we're happy that more than 25% are from abroad. And we, of course, are involved in different national and international projects. And one of research topics are crop breeding. So different agricultural crop varieties are registered and propagated then not only in Europe, but also in Canada and US, especially for grasses. And we have strong collaborations with business entities. The main research fields that we work, it is biopotential of plants. We try, especially in the changing climate, we're trying to introduce new crops to the country, analyze how they can survive and analyze their productivity and quality. Sustainable forestry, focus on forest research, plant protection in all fields. It is agriculture, horticulture, and forestry, smart horticulture. We have experiments in the controlled climate and field tests, and soil quality and productivity. A lot of research is done on the soil quality, and we evaluate new technologies, new soil tillage technologies, as well as new fertilizers. And then genetics and breeding, already mentioned that new crop varieties development is one of our topics. And today I'm going to talk about the use of digestate for crop fertilization. Jonas already started a bit. And let me start shortly about the process for those who are not familiar with the anaerobic digestion. That is organic wastes. They are anaerobically digested. Waste can be different type. That is manure, different types of manure, wastewater treatment, sludge, different organics, grasses, for example, that are cut. They digest it, and the main product that goes is biogas, which is mainly used for the electricity, heat. Also biomethane. It is becoming more and more popular in Europe, but still needs a lot of investment for cleaning the biogas. And it is used for the injection of grit. And digestate, here it is shown that it is used for fertilizers, but still there are a lot of questions how to do that in the sustainable way and how to do. If we would see, this is the picture from World Biogas Association. The biogas production is more or less stable, or was the slight increase. I was really surprised that Europe has much higher biogas production than US. It was very high investment in renewable energy, and most of the countries invested a lot, especially Germany, and a lot of new biogas plants are built, and owners get support. That was the main reason for the increase for biogas. And digestate, there's always the question, it is the residue or secondary product, which could be effectively used for the fertilization. And first of all, let me start with the digestate as a product. It could be liquid. It goes from the biogas plant as a liquid phase, and also separated, which is like more or less like manual, and it has less humidity than manual does. And separated, it's much more easier to transport. You don't need so many investment for transportation, but the nutrients are mainly in organic form, and it's difficult for plants to use it. So it takes more time until you get the effect. If we look at the quality of digestate, for the liquid, the dry matter is up to 1% in natural matter, and in separated, we have about 25-30% of dry matter. pH is more or less the same, and total nitrogen, this is in natural matter. In liquid digestate, we have from 0.15 up to 0.65, and in separated, it's enriched, as it is only water is excluded, and it is much higher. The same was phosphorus and potassium, and the quality of digestate depends very much on the raw material that was used for biogas production. If we put, for example, chicken manure for the digestion, it will be very rich in phosphorus. And if we have pig manure, it will have more nitrogen on it. So it depends very much what you put. And we need to be very careful. I will speak a bit later when we use residues for anaerobic digestion. We had one experiment when we took digestate from the plant, which works also as residue utilization, and they put there also dead animals and residues from food industry. So such digestate was contaminated with heavy metals and could not be used for fertilization. So we had I started to work with digestate in 2007 when I started my PhD, and now I have the team who also does the work, and also that was part of the work for Carolina and Donata. They will also present some results, and we applied digestate for different crops and analyzed the effect of crop productivity, grain and biomass quality, soil quality, greenhouse gas emissions, and energy efficiency. We started with the laboratory experiments, and could see that I will say that today I will present our results from one experiment where we used 3 types of digestate, that is cow manure digestate, pig manure digestate, and chicken manure digestate. And we had, laboratory and field experiments, and we started with the laboratory experiment, and we saw that biomass production, if we used cow manure digestate for fertilization, was higher. And if you use digestate for crops, it is very important also to know what soil quality do you have and soil type. If you would see that in loam soils, the most effective was cow manure digestate, while in sandy loam, pig manure digestate and chicken manure digestate had the higher effect. That is because of different elements are missing in soils that digestate could compensate and had a higher increase on yield. This is the process how we did the experiments, and you can see the digestate, how it looks in reality. This is from chicken manure digestate. And when we went to the fields, for the first year of the experiment, we saw that fertilization with mineral nitrogen still had high effect for crop productivity than the use of different types of digestate. The fertilization rate was calculated according to total nitrogen in digestate, and we had the same norms in there. But we can see that even by eye, compared to the control, the effect was really visible. What it is, would say, obvious, and what we also found out that if you want to get the high effect, you need to use digestate for at least few years. For the first year of the experiment in the same plots, when we can say the highest yield, this is the same graph, the highest yield was when we applied mineral fertilizers, and then it decreased with the digestate. For the second year of the experiment in the same field, we already didn't get any significant difference between treatments when we used mineral nitrogen and other crops. But also what we can say, it was very dry conditions. It was very dry conditions, and maybe that could be affected that fertilizers were not accepted. But for the third year, we already saw increase in grain yield, and digestate has a cumulative effect. So that is mainly because we have our nutrients in organic forms. So it takes time to mineralize all the mass and microorganisms to adjust to the new conditions, and then we already start to get better results. We were very happy that the content of proteins in all crops were very good. It was more than 11% in spring wheat, so it's more or less normal, and that means that it was enough nitrogen for wheat to accumulate enough proteins. In another experiment, we also tried to use some additional synthetic fertilizers together with digestate to increase the quality, and it had positive results also. Talking about nitrogen use efficiency, for the first year of the experiment, when we used digestate, nitrogen use efficiency was very low because of the low yields and not that good that we expected. Similar as the yield for the second year, it was better, and for the third year, we had better results when applied different digestates. And yes, cow manure digestate presented the best results. As I would say, cow manure digestate didn't have so high variation nutrients. It was more stable in the quality that was applied. Very important, the soil chemical composition and what we have on the soils. We tested the main elements, and what we can see that the lowest potassium concentration difference was the pig manure digestate, and still we had very nice increase. And cow manure digestate affected to the higher phosphorus concentration in the soil. So that was also after 3 years of the experiment, that is also accumulative effect. While in our control or synthetic nitrogen fertilizers, they were lower. We did experiments with greenhouse gas emissions. We had transparent chambers that we put on the soil and measured greenhouse gas emissions, that is CO2 and CH4. I present here only CO2 because there were no differences for other gases. But for CO2, what we found interesting, and I think it was not unexpected, that after the application, the CO2 increases in most of the treatment. That means that microorganisms start, I would say, to change a bit in the communities, and there is a higher respiration from the soil. And the same was also after the second treatment, we can see an increase. And later on, there are no differences. So we can say that application of digestate are the same in greenhouse gas emissions as other treatments. We did microbial community analysis, and it was, I don't have the picture here. It was found that there are no changes in microbial communities, but there was changes in microbial biomass in different treatments. And yes, after 3 years of application, we had significant results that digestate application increased microbial biomass in the soil. So the main benefits, increased of biomass productivity. At least we can compare to synthetic fertilizers, improved soil quality, reduced synthetic fertilizers for crop management. But as well, there are some traits which are also correlated with the benefits a bit. First of all, it is unstable quality. As I mentioned, it depends very much on the biomass, what is put to the anaerobic digestion. And if something changes in the process, everything is presented in digestate. It is about 90% what you put to the digester, it comes out with digestate, and only organic matter, organic carbon is digested during the process. What is one of the interesting things that biogas production was killed when stopped, when owner decided to put residues from spirit production, and it was okay at the beginning, and then she decided to come back to the manure and other organic materials, and bacteria just died. They didn't want to get back to other residues, and they wanted to the spirits. Yes, contamination risks. I already talked a bit. It is heavy metals, but not only heavy metals. That could be also pesticides or other things that could be presented in biomass. But for this, there are already some solutions. You can use like preheating of the biomass before the digestion, but of course, then also different processes in chemical composition start. There would be also the need for nutrient enrichment. For example, if pig manure digestate, it is really not very rich in nitrogen, and if we use liquid, you need to apply, I know, about 70 tons of liquid per hectare. So that means that you need to spread a huge amount, and we need somehow to enrich. We need special equipment for fertilization. So if farmers decide to use, so we need to buy and invest to the process. And if it's raining, nitrogen leaching is much more dangerous because it's in liquid form or in organic, but leaching is very increased. Greenhouse gas emissions, I talked about CO2, but I would say that we were happy with the very nice weather conditions. But if it is very hot and you spread the fertilizers, so they can start emitting nitrogen, and still there is question. Some farmers already use incorporation into the soil, so they spread already with some soil treatment and try somehow to cover the digestate and to get better results. Yes, and expensive transportation. It is beneficial to use digestate if you have your own biogas plant and you have land around. So it is very nice. Otherwise, it is quite expensive, and this price somehow could reduce. So, but I think we are a very nice team here, working in different fields. Already Jona started to speak how can we use digestate for different purposes. So I hope that during those days, we will find some solutions how to change those. Thank you very much.